Let us look at these examples from indices and logarithms from pre-calculus. F of x is equal to 4e to the negative x over 5. Find f of 6. So, here now, f of 6 would be equal to 4e to the negative 6 over 5. Alright? Now, let's work it out using our calculator. So we have negative 6 divided by 5 is negative 1.2. Now, we want e raised to that power. We have e raised to the power of negative 1.2 equal, and that is 3.01. Multiply that by 4 times 4 equals, I will get 1.2. Alright? So our answer here is equal to 1.2. Now let's look at this. Question 2a. We have the log of 9, the base of the log is 3, and the log of 9 with a base of 3 is equal to x. What is x equal to? Remember now, you want to rewrite this from logarithmic form to index form. Index or exponential form. Now, remember, if you don't remember how to write it, something else is a bit easier to remember. You can work it out. The log of 1,000 is equal to what? Let's get back to our calculator. If you don't remember what the log of 1,000 is, we have, and remember it's log we're dealing with, base 10 log 1,000 equals 3. It is equal to 3. And this is common log. It has a base of 10. When you rewrite this, let me circle it, put a mark around it. When you rewrite this in exponential form, you're going to say that the 10 raised to the power of 3 is equal to 1,000. So 10 raised to the power of 3 is equal to 1,000. So you have this statement in logarithmic form and exponential form. Let's rewrite this now. Just like how you said, 10 raised to the 3 is 1,000, so that the base of the log in log form. Now in exponential form, it becomes the base of the exponential form. So it's 3 is the base, it's 3 raised to the power of. 10 was the base in log form, it's now 10 raised to the power of. The number you're finding the log of was 1,000. In exponential form, it becomes the answer. So you say equal to, the number you're finding the log of here is 9. In exponential form, you say it's the answer equals 9. In logarithmic form, the answer was 3. You say equals 3. Now it becomes the exponent right here. You say to the power of 3. So here the answer was x, so here it says to the power of x. Now 3 to what power gives you 9? Remember now, you could say 3 to the 1 is equal to, well, that's 3, so it's not 1. Let's try 2. 3 to the power of 2 is equal to 3 by 3, which is 9. Alright, so therefore, this is saying 3 to the x will be equal to 3 to the 2, which is 9. So x must be equal to 2. Alright? So x is 2. Alright, so that's that. Now let's look at 2b. Oh, 2b is similar. I'm going to use the same argument for 2b. Here now, we have 2 times log of 8 equal x and the base is 2. Now the thing is, remember, when you have a number times the log, it means the log of the number raised to the power to that power. Is, for example, suppose you say 3 log 5 and the base is 10. What is that equal to? We're using common logs, that is logarithm with a base of 10. So let's get back to our calculator and see what happens here. What we have is the log, alright, let's say 3 multiplied by the log of 5 equals, we say 2.0969. Suppose now I raise 5 to the power of 3. 5 to the power of 3 is 125. And I find the log of 125. Will it be the same 2.0969? Let's see. 2.0969. Alright? Now, this means the same as the log of 5 to the 3, and the base is 10, right? You use the same argument here. I'm going to say 2 log 8 with the base 2 is the same as log 8 to the 2, and the base is 2, right? Equals x. Make sure you follow. Now, here, 8 squared is 64. So you're finding the log of 64 equals x, but remember now the base is 2. Now, rewriting this from log to exponential form, remember now, you're going to say 10 to the 3 is equal to 1000, following the same pattern. 2 to the x is equal to 64. So 2 to the x is equal to 64. You see that? Now, how many 2's must multiply to give us 64? Whatever that is going to be x. Alright? Now, the root of 64, that will give you 2, can also be considered to work. Now here, 2 to what power will give you 64. Now the thing is, you, in this case, could work it out using the change of base rule at this point. But you could also work it out by finding how many 2's multiply together to give you 64. Let's do it both ways. 2 times 2 is 4. A third 2 gives you 8. 2, 2, 4, 4, 2 is 8. 8, 2, 16. 16, 2 is 32. 32, 2 is 64. Alright. 2 times 2 times 2 times 2 times 2 times 2 gives you 64. Alright. 1, 2, 3, 4, 5, 6. There were 6 2's is equal to 6. So, I mean 64. So x in this case would be equal to 6. Now, here we have another way where you say the log of 64 is x. Let's put x over here. X is the log of 64 and the base is 2. What the change of base rule says is this is going to be the log of the number and with using a different base over the log of the base. Let's use common log. Or we could use ln 2. You could also say ln 64 over ln 2. Let's try using those methods and see if we get 6. Log 64 divided by log 2 equals, let's see, 6. Could also say ln 64 divided by ln 2 equals 6. Alright? So in our cases, you get 6 for the answer. So x is 6. You use whatever method you want to use. Alright? Unless otherwise specified. So x is 6 in this case. Let me erase some more of these things. So let me just make a note here that x is equal to 6. Now we're going to solve for x in question 3a. Now, here, you know that if you had 5 to the x equal 25, you know that x would be 2. That's plain, straightforward. You also know that 5 to the x is equal to 125, x would be 3, right? But we say 5 to something equal 30. Whatever that thing is, it must be between 2 and 3. So it's going to be 2 point something. But anyway, let's figure it out. You're going to have to use logarithms. You have 5 to the x plus 1 is equal to 30. Let me put x plus 1 in brackets. Log both sides. The log of 5 to the x plus 1 is equal to the log of 30. Now you know when you have the log of a number to a power, it's the same as the power times the log of the number. X plus 1 times the log of 5 is equal to the log of 30. You see that? Then, if you divide both sides by log 5, you have x plus 1 is equal to log 30 over log 5. You could work out log 30 over log 5. What is log 30 divided by log 5? Let's see. Log 30 over log 5 equal. Alright, call it 2.113. 2.113. Now you have to subtract from 1 in order to get x. So you have x equal. Subtract this from this, you have 1.113. So x is equal to 1.113. Right? So, remember now, this is saying x plus 1 is 2.113. And I said before, it's between 2 and 3, so it's 2 point something. When you take the 1 away from the x plus 1 now, you have 1.113. Alright, so the answer for this says x is equal to 1.113. Alright, we have part 3b to deal with now. Let's look at how it goes. Here, you have log 128 minus log 2. Minus log 132. Log 138 minus log 132 is equal to x. Of course, the base of the log here is 4. Now, remember what you do when you have the log of a number minus the log of another number with the same base. It's somewhat like you're saying log 5 minus log 3 is going to be log of 5 over 3. Remember the laws of logarithms, right? Let's just examine that with our calculator and verify it before we move on. We have log 5 minus log 3 equals. 0.221. Let's try ln as well. ln 5 minus ln 3 equals, here is going to be 0.510, but that's because we use a different base. We use natural logs different from common log. But let's stick to natural logs for this example, and then we try common logs and see. So log 5 over 3 is 0.22, call it 0.2218. So we have 0.2218. I was ready to write here. Alright, now we're ready to write what log 5 over 3 is. Is log 5 over 3 the same thing as the same 0.2218? Will we get the same thing? Let's see. The log of, open bracket, 5 divided by 3, close bracket, equal 0.2218. Alright, 0.2218. Let's try ln now and see what we will get. We're going to find ln 5 minus ln 3 and see what it is. We're also going to find ln 5 over 3 and see if it's the same thing. Alright? And then we go back to our question. So, ln 5 minus ln 3 equals 0.51, call it 0.5108. What about, alright, so we have the 0.5108 here. What about ln, open bracket, 5 divided by 3, close bracket, equal 0.5108. We get the same thing. So this is 0.5108. This is 0.5108. So therefore, with a different base, it works out. Right? It always works out. So here now, the base now that we're using is base 4. So this should be the log of 128 over 32 when the base is 4, and that is equal to x. Alright? What is 128 divided by 32? 128 over 32 equal 4. So this is the log of 4 with a base of 4 equals x. Now let's rewrite in exponential form. Remember our exponential form? You're going to have 4 raised to the x equals 4. Alright? That's what's going to happen. So 4 raised to the x is equal to 4. What must x be? 4 to what power gives you 4? It's 1. So x equals 1. Alright, so that's it for now for these examples.